Good morning, please bear with me. I have a scratchy throat and flu setting in. So we have another question to answer. If the coefficient along the incline is 0.18, calculate the frictional force of the trolley as it moves up the slope and the applied force of F. We have been given the following. The mass of this trolley is 5 kilograms. The incline angle theta is 30 degrees. The coefficient of kinetic friction is 0.18. The acceleration up the incline is 0.45 meters per second squared, and the gravitational acceleration is 9.8 meters per second squared. Right, let's have a look at calculating first normal force, then frictional force, and then the applied force. So having a look at step 1, which is the calculation of normal force. And on an incline, normal force is N equals mg cosine theta. Right. Then we start substituting the given values. The mass was 5. The gravitational acceleration is 9.8 multiplied by cos 30 degrees. So 49 times 0.866 after the calculation, we get an approximate value of 42.43 newtons, and that is the normal force. So in step 2, we need to calculate the frictional force. So Fk is equal to the coefficient of the kinetic friction multiplied by newtons. Now we got the value of the coefficient of the kinetic friction at 0.18, and we just calculated in the previous step the normal force, which gave us 42.43 newtons. When you multiply the two, you get an approximate value of 7.64 newtons. In step 3, we need to calculate the applied force, and we will use Newton's second law along the incline, positive direction or up the incline. So our formula for step 3 is Fa minus Fk minus mg sine theta equals to ma. When we break it down, we got the mass of the trolley at 5 kilograms and the gravitational acceleration at 9.8 meters per second squared, right? Then, when we calculate all of that, we finally end up with 49 multiplied by sine 30 degrees because they gave us the angle theta at 30 degrees. So now it's 49 multiplied by 0.5, and the answer for that calculation is 24.5 newtons. Now we substitute into the formula up top, right? 7.64, which was the frictional force, minus 24.5 after we broke down mg sine theta, which is equal to 5 times 0.45, and the answer for that calculation is 2.25. Now, Fa is equal to 2.25 plus the 7.64 of the frictional force plus the 24.5 after the breakdown, which leaves us with an answer of 34.39 newtons. Good luck with your exam. I hope this helps.